On September 8th, Bun version 1.0 was released, creating a buzz in the JavaScript community. You might be wondering, what is Bun? Why was it developed? And why are comparisons being drawn with Node.js? In this video, we will dive into Bun, explore its features, and see how it compares to Node.js. Timestamps are provided, so please feel free to jump to the section you're more interested in. So what is Bun? Bun is a super fast, all-in-one toolkit for JavaScript and TypeScript apps. The beauty of Bun lies in its ability to streamline the development process, making it smoother and more efficient. This is possible because Bun is not just a runtime, it's also a package manager, a bundler, and a test runner. Imagine having a Swiss Army knife for JavaScript development. That's Bun for you. But why was Bun created? The inception of Node.js in 2009 was groundbreaking. But as it expanded, its complexity grew. Consider it like a city. As it grows, traffic congestion can become an issue. Bun aims to be the new infrastructure that alleviates this congestion, making things run smoother and faster. It's not about reinventing the wheel, but refining it, ensuring we get the speed and simplicity without losing the essence of what makes JavaScript unique and powerful. But what about Deno? When discussing the evolution of JavaScript runtimes, it is hard to overlook Deno. Ryan Dahl, the creator of Node.js, introduced Deno as a new runtime that aimed to address some of the challenges and regrets he identified with Node.js. Deno is a secure runtime for JavaScript and TypeScript, addressing many of Node's shortcomings. However, its adoption hasn't matched that of Node's, so this video will focus on contrasting Bun with Node.js. Let's get started by making sure we have a Node and a Bun project to work with. In one VS Code window, we have a folder called Node Playground. Here, we will create another folder called Node1 and navigate inside. We will run the command npm init-y to create a package.json file with defaults. We will also create index.js, where we will write our Node.js code. In the terminal, run node index.js, and we see hello node being logged. Similarly, in the second VS Code window, I have a folder called Bun Playground. Here, we will create a new folder called bun1, navigate inside, and run the command bun init-y. This will scaffold an empty project. The command generates a few files, and in index.ts, we already have a console log statement. In the terminal, run the command bun index.ts to see hello via bun logged. Both our projects are set up and ready for more code snippets. Let's now dive into comparing Bun with Node.js. Our first topic is Bun versus Node.js as a JavaScript runtime. A JavaScript runtime is an environment which provides all the necessary components in order to use and run a JavaScript program. Both Node and Bun are runtimes. Node.js is primarily written in C++, whereas Bun is written with a low-level general-purpose programming language called Zig. But that is just the tip of the iceberg. Let's take a look at other differences when treating Bun as a runtime alone. The first subtopic is JavaScript Engine. A JavaScript engine is a program that converts JavaScript code we write into machine code that allows a computer to perform specific tasks. While Node uses Google's V8 engine that powers Chrome browser, Bun uses JavaScriptCore, which is an open-source JavaScript engine developed by Apple for Safari. V8 and JavaScriptCore have different architectures and optimization strategies. JavaScriptCore prioritizes faster start times and reduced memory usage with a slightly slower execution time. On the other hand, V8 prioritizes fast execution with more runtime optimization, which may lead to more memory usage. This makes Bun fast, starting up to 4 times faster than Node.js. The second subtopic is Transpiler. While Node.js is a powerful runtime for JavaScript, it doesn't natively support TypeScript files. In our Node Playground, in a new folder, Node2, run npm init-y. create a file index.ts. Within the file, let's define an add function. It accepts two parameters, a and b of type number, and returns their sum as a number. We call the function and log the sum value to the console. In the terminal, run node index.ts, and we see an error. To execute TypeScript in a Node environment, external dependencies are required. One common approach is to use a build step to transpile TypeScript into JavaScript and then run the resulting JavaScript code. Let me show you a basic setup that uses the tsnode package. In the terminal, npm install as a dev dependency TypeScript and tsnode. In package.json, you can set up a new script. Start tsnode index.ts. With this script in place, you can run your TypeScript file with Node.js using the command npm start. We see the sum of 5 plus 3, 8. In contrast to Node.js, Bun offers a more streamlined approach. It comes with a JavaScript transpiler integrated into the runtime. This allows you to directly run JS, TS, JSX, and TSX files. Bun's built-in transpiler seamlessly converts these files to vanilla JavaScript, facilitating immediate execution without additional steps. In the Bun playground, create bun2, navigate inside, and then run bun init-y. In index.ts, paste the same function and run bun index.ts. We see the same output, 8. The difference in speed between Node.js and Bun is magnified when running a TypeScript file, as Node.js requires a transpilation step before the code can be run. Alright, for the third subtopic, let's talk about module system compatibility. A module system allows developers to organize code into reusable segments. In JavaScript, the two primary module systems are CommonJS and ES modules. CommonJS, originating from Node.js, uses require and module.exports for synchronous module handling, ideal for server-side operations. ESM, introduced in ES6, employs import and export statements, providing a more static and asynchronous approach optimized for browsers and modern build tools. Let's use colors for CommonJS and chalk for ESM, two popular packages for adding colored outputs to the console, and better understand the difference in Bun and Node.js. Now, Node has been traditionally associated with the CommonJS module system. Let me create a new Node project, Node 3, navigate inside, and run npm init-y. Also run npm init colors and chalk. Create a new index.js file. For the code, we're going to require the colors package and log colors.green hello world. Run the code, and we see hello world in green. Pretty straightforward to work with the CommonJS module system. If we replace require with import colors from colors and rerun the code, you can see there is an error. Cannot use import statement outside a module. To run ES module in Node.js, you have one of two options. First, you need to include type set to module in package.json, or you can use the .mjs file extension. So rename index.mjs. We run node index.mjs, and we see the expected output hello world in green, this time with ES modules. This transition from CommonJS to ES modules has been a complex journey. It took Node half a decade post ESM's introduction to support it without the need for the experimental flag. Still, CommonJS remains prevalent in the ecosystem. Bun simplifies the module system by supporting both CommonJS and ESM without any special configurations. Bun's standout feature is its ability to support both import and require in the same file, something not natively possible in Node.js. In Bun Playground, let's create bun3, navigate inside, and run bun init-y. Let's also add colors, and chalk packages. We can now import chalk from chalk, but require colors from the colors package. Run bun index.ts, magenta colored hello from chalk, and cyan colored hello from colors. With bun, you can run code using CommonJS syntax, ESM syntax, or even mix of the two modules in the same file. This, if you ask me, is incredible. For the fourth subtopic, let's discuss web APIs. Web APIs are integral to browser-based applications and offer tools like Fetch and WebSocket for web interactions. While these have become browser standards, their support in server-side environments like Node.js has been inconsistent. In earlier versions of Node.js, web standard APIs commonly available in browsers were not natively supported. Developers had to rely on third-party packages like Node Fetch to replicate this functionality. However, from Node version 18, there is experimental support for the Fetch API, potentially eliminating the need for these packages. Bun, on the other hand, simplifies this by offering built-in support for web standard APIs. Developers can directly use stable, fetch, request, response, WebSocket, and other browser-like APIs without any additional packages. Furthermore, Bun's native implementation of these web APIs ensures they are faster and more reliable compared to third-party alternatives. With the power of editing, we now have the Node 4 and Bun 4 project with the exact same code making a fetch request to JSON placeholder API. In the Node.js environment, running node index.mjs will log Leanne Graham, and so does running bun index.ts. While the fetch API is experimental in Node.js, the same is already stable in Bun. Alright, let's move on to the fifth subtopic, hot reloading. Hot reloading is that feature which instantly reflects code changes in the application without the need for a full restart. In the Node.js ecosystem, you have a couple of options for achieving hot reloading. One popular tool has been nodemon, which hard restarts the entire process. You can globally install the package and run a file using the command nodemon index.js. Alternatively, starting from Node.js version 18, there is an experimental watch flag introduced which you can use. In the same Node 4 folder, node-watch index.mjs. We see the experimental warning and the username. Change user's parameter to 2, save the file, and the code is rerun and we see a different name. Both nodemon and the watch flag aim to provide real-time reloading of the application as the code changes. Bun, on the other hand, takes hot reloading a step further. By running bun with the hot flag, hot reloading is enabled. Unlike the Node.js methods that might require a full process restart, bun reloads your code in place without terminating the old process. This ensures that HTTP and WebSocket connections remain uninterrupted and the application state is preserved, providing a smoother developer experience. So run bun --hot index.ts for hot reloading. Change the ID to 2, save the file, and we see a different username. For our final subtopic under the JavaScript Runtime topic, let's discuss Nodejs Compatibility. While transitioning to a new runtime or environment, compatibility is often a primary concern for developers. Bun addresses this by positioning itself as a drop-in replacement for Node.js. This means that existing Node.js applications and NPM packages can seamlessly integrate with Bun without any modifications. There is already support for built-in Node modules such as fs, path, and net, recognition of global variables like _directory name, process, etc., as well as adherence to the Node.js module resolution algorithm, including the familiar node modules structure. Let me show you an example. In the same bun4 folder in index.ts, let me paste the following code. If you're familiar with Node.js, it should be clear we are working with Node's fs module. If I run bun index.ts, You can see the code runs without an issue. We read the file, package.json, and log the file contents to the terminal. We also have a write file, content hi again, to index.html, which we can verify. You can simply drop in your Node.js code into Bun, and it just works. It's not 100% compatible, but the Bun team is working hard to close that gap. But here's the thing. While Bun ensures compatibility with Node.js, it doesn't stop there. Bun ships with highly optimized standard library APIs for things you need most as a developer. For example, the same code we can replace with Bun APIs. We have bun.file to read package.json, await file.txt, and bun.write to write content into index.html. We have the output and the updated HTML. Bun.file is 10 times faster than fs.readFile, and bun.write is 3 times faster than fs.writefile. There are other Bun APIs to create an HTTP server, work with a SQLite database, and even passwords. The bottom line is Bun APIs are super fast compared to Node.js APIs. With that, we have covered our first topic of comparison, the JavaScript runtime. The next topic of comparison is Bun versus Node.js as a package manager. Bun is an advanced toolkit that includes a powerful package manager. If you have ever found yourself patiently waiting during dependency installations, Bun offers a refreshingly faster alternative. Here is a table comparing Bun commands with npm, which is Node's package manager. We have bun install, bun add package with the --dev option, bun remove package, bun update package, and bun run script. At a glance, Bun's commands might seem familiar, but the experience is anything but ordinary. Bun boasts installation speeds that are orders of magnitude faster than npm. It achieves this by leveraging a global module cache, eliminating redundant downloads from the npm registry. Bun employs the fastest system calls available for each operating system, ensuring optimal performance. Here is a speed comparison of installing dependencies for a starter Remix project from cache, comparing Bun and npm from the official Bun website. We also have pnpm and yarn for added context. Make sure to also check my video where I compare setting up a new Next.js 13 project with npm and Bun. Bun is almost 10 times faster when installing from cache. Node's npm has been the standard for JavaScript package management for years, but Bun really is a speed powerhouse and presents a compelling alternative. Alright, for our third topic, let's take a look at Bun versus Node.js as a bundler. Bundling is the process of taking multiple JavaScript files and merging them into one or more optimized bundles. This process can also involve transformations such as converting TypeScript to JavaScript or minifying the code to reduce its size. In the Node.js ecosystem, bundling is typically handled by third-party tools rather than Node.js itself. Some of the most popular bundlers in the Node.js world include Webpack, Rollup, and Parcel, offering features like code splitting, tree shaking, and hot module replacement. Bun, on the other hand, is designed to bundle JavaScript and TypeScript code for various platforms. To bundle with Bun, you can use a simple build command. With the power of editing once more, I've created a new Bun project called Bun5, which has a users.ts file which exports a getUsername function, returning user.name, and index.ts file which calls it. We can build this app using the command bunbuild./index.ts, and we specify the output directory as ./build folder. This command bundles the index.ts file and outputs the result into the build directory. We have index.js created, the same getUsername function, and the call to get username from index.ts. The bundling process is incredibly fast, with Bun being 1.7 times faster than ESBuild and significantly outpacing other bundlers like Parcel and Webpack. But a standard feature in Bun is its introduction of JavaScript macros. These allow for the execution of JavaScript functions during bundling, with the results directly inlined into the final bundle. In index.ts, update the import statement to include with type macro. If you run the build command once more, you can see instead of making a runtime API call, the macro fetches the data at build time, inlining the result directly into the final output. While Node.js has its established building tools, Bun offers an integrated, faster, and innovative alternative that could reshape how we bundle applications. For the fourth and final topic, we have Bun versus Node.js as a test runner. Testing is a crucial aspect of software development, ensuring that code behaves as expected and catching potential issues before they reach production. In addition to being a runtime, a package manager, and a bundler, Bun is also a test runner. While Node.js has traditionally relied on Jest for testing needs, Bun introduces a built-in test runner that promises speed, compatibility, and a range of features that cater to modern development workflows. Bun's test runner, Bun Test, is designed to be fully compatible with Jest, which is a testing framework known for its expect-style APIs. This compatibility ensures that developers familiar with Jest can easily transition to Bun without a steep learning curve. Executing tests is straightforward with the bun test command. Create index.test.ts and create a simple test of adding two numbers. Run bun test, and we see our test passing. Moreover, Bun's runtime supports TypeScript and JSX out of the box, eliminating the need for additional configurations or plugins. Bun's test runner is not just about compatibility, it's about speed. In a benchmark against the test suite for Zod, Bun proved to be 13 times faster than Jest and 8 times faster than vtest. This speed advantage is because of Bun's matchers, which are implemented in fast native code. Whether you're looking to migrate existing tests or start a new project, Bun provides a robust testing environment that aligns with modern development needs. Node.js has long been a cornerstone in the JavaScript world, setting benchmarks and guiding developers. However, Bun is stepping onto the scene as a noteworthy challenger, pushing boundaries. While it's still early days for Bun, the buzz it is generating is undeniable. Currently, it's optimized for macOS and Linux, and while Windows support is in progress, some features are still on the horizon. But with everything it offers, Bun is certainly a toolkit you should consider exploring.